So 7.3, very similar to 7.1 and 7.2. The only difference is right now we're focusing on the population proportion rather than the sample mean, right? Or the sample proportion, right? So in this particular case, what we have here is we have another formula that's going to allow us to determine what the error is, so we can figure out a confidence interval for the proportion. So the example that we have provided for us here is basically the sample proportion equals 7 over 20, or 0.5, so there's a 0.35 chance that something potentially would happen. We could look at it like that. And there's a 0.65 chance, right? I'm not writing it here, but there's a 0.65 chance that something maybe wouldn't happen, right? So it's two choices, either one or the other. And we want to know, we want to look at a 90% confidence interval that it would in fact happen, that this would fall true, right? On a 90% confidence interval. So to do that, we need to calculate the error. So to calculate the error, we're going to go ahead and plug in what's given here. We have 0.35 plus or minus. Now, we need to figure out what z is going to be. First, we need to figure out what alpha is. We know that alpha is going to be 1 minus 90, or 0.90, which is 0.10. And we can say that our confidence interval is going to be alpha divided by 2, which is going to be 0.05. Okay? So that's what we're going to be looking up in our chart, our normal table. And then, we have to calculate this here. So this is the sample proportion, right, on the bottom. We can go ahead and, I don't know if I gave us what the what n is. So we'll say that n is 20. Okay? I forgot to list that there because we need to how many samples we are taking. So if n is 20, and then in the numerator we're going to have 0.35 times, this is actually where I was saying, if we have a 35% chance that it's true, then we have we do have a 65% chance that it's not true. That's exactly what this is, because all we're doing here is subtracting the sample proportion from 1. And when we do that, we're going to get 0.65 here. Okay? So now the next step is now go into our z-table. Okay, so here we are. We're on our second page of our standard normal table. And when we take a look here, we're going to look for 0.05. So really 0.05 is going to fall somewhere smack dab in the middle between these two values, which would be between 1.64 and 1.65. So we would call it 1.645 would be the value, 1.645. Okay, and we have now written 1.645 right in here, so now we're just going to bring down the 0.35 plus or minus. Remember, that's our z-score. We're going to go ahead and simplify this. When we simplify it, it ends up being 0.107. We're going to multiply these values together. When we do that, we get 0.35 plus or minus 0.175, and now we can go ahead and write our confidence interval. And so our confidence interval here is going to be 0.175, comma, 0.525. Now the one thing you need to remember here is we are dealing with a proportion. So what does this actually mean? This means percentages here. So we can say that we have a 90% confidence that our population proportion will fall between 17.5% and 50%. So right now we're going to jump right into 7.4. This is the last section in Chapter 4 that we cover. And 7.4 talks about sample size considerations for estimating a population mean as well as a population proportion. So there are some formulas here that you'll need to know. And again, this is something you're going to want to cut and paste and maybe put in a formula sheet. So sample size considerations for estimating a population mean. Basically, within E units at 100%, times whatever 1 minus alpha is confidence interval. Basically, at the end of the day, you're going to figure out what that sample size is, what that recommended sample size is, by multiplying whatever your z-score is, sub alpha divided by 2, all squared, times the standard deviation, that's the population standard deviation, squared, divided by the margin of error squared, okay? And at the end of the day, we need to round that up. So the next slide here just talks about an example. It just runs through that example of how you get it, and basically they're telling us that the sample size should be 281 in order for us to feel good about this here, okay? And next, now we're just talking about p. This is p hat here, so don't, p hat meaning p with a little caret over it, right? So in order to figure out what the confidence interval is, or what the recommended sample size is for a particular confidence interval, what we would want to do is plug into this formula. And this formula is very similar from the previous formula. The only thing here is you're just taking the population proportion, right? And you're going to multiply it times 1 minus the population proportion and divide it by the margin of error squared. And then we have another example here that will kind of run you through that. Notice this example says that you need to have at least 752 pieces of data in order to be able to say that we can move forward with confidence on this.